All right, welcome back to statistics. Today we are going to do confidence intervals with proportions. Okay, I'll try to split it up into two because I don't like to give you guys hour-long videos. It's not good. So here we are. All right, we cannot minimize recording. Very good. Let's share a screen now, because that's really what I meant to do. Okay, and let's go over here. And the nice thing is, like, I hope doing confidence intervals is becoming a little boring because you're like, I could do this already. I could do this with multiple different ways. We're going to do it with one more. But if it's starting to get easy for you, like, okay, I got this. Please stop beating the horse. That's great, because I'm going to ask you questions about finding confidence intervals, and you have to figure out which one you have to do. Okay, so if you're in a position now where you're like, this is pretty, it was hard at first, but now it's pretty easy. Like, that's fantastic. I want you to think like we got more than halfway through stats, and all of a sudden it got easy. Like, who wouldn't like that? So what we're going to do here, okay, is let me just explain what's going on. Okay, so now we're going to talk about proportions. Okay, so first thing to know about proportions is that it has to be between 0 and 1. Okay, the notation is, this guy is called p hat. Okay, it is the estimate of the proportion you're looking for. Okay, now p, that is the true proportion. Okay, I mean, I wish we could use pi because that's the Greek p. It would follow in being a parameter like the other ones are, like mu and sigma, but pi already has a job, so we don't really use it for that. Okay, so p hat is the estimate of p, and then the true proportion is just p. All right, so it has to be between 0 and 1. All right, and what we're trying to do is, well, we have to make sure, because it has to be between 0 and 1. So here's 0, here's 1. So if we're going to be looking for, like, you know, here's my p, and then my p hat estimate looks something like this. Do you see a problem on my distribution here about maybe it gets a little cut off? We don't want to have that happen. Okay, so what we're going to do is we're going to say, well, we have to check. I'm trying to remember exactly which one your book goes with. I think it goes with 10. Okay, I've seen some books use 5, some books use 10. It depends on how conservative you are. Okay, that's not a political thing. That's a, how cautious are you? Okay, and generally in sciences, we want to be pretty cautious. Okay, so I think your book uses this one. Okay, so what it's saying is that p and n minus and 1 minus p times the n has to be bigger than 10. And that pretty much assures that even if we get to like something over here as a p, right, that we're going to still get a distribution like that for it. Okay, even if it's the beginning. So we could push it really close, but no matter how close we push it, like, because of this, it kind of makes the distribution here, like, we could blow this up. Right, here's our 1. Right, and instead of being like this might be 0.01 or something, we'd still get like that kind of a thing. Okay, because there's, the length is 1, but there's like an infinite number of numbers between 0 and 1. Like, I don't believe you. Right, well, there's 1 over 2, 1 over 2 squared, 1 over 2 cubed, 1 over 2 to the 4th. Okay, dot, dot, dot. There's also 1 over 3, 1 over 3 squared, 1 over 3 cubed, dot, dot, dot. And that is going to include stuff like 1 over pi, 1 over pi squared. Okay, all sorts of things like that. So yeah, there's an infinite amount of numbers between 0 and 1. And all this does is make sure that we can just kind of scooch in there and make some more room. Okay, so kind of a weird thing to think about, but yeah, that's what we're doing. We just don't want it to be too close to the edge, and this ensures the fact that it's not going to be too close to the edge, and that even if it is, like, because of this multiplication thing here, it kind of scooches in and puts itself into that area to be able to have enough room. Okay, so that's the only thing we really have to worry about. The other thing, like if we're going to do this by hand, we're not, but this calculation is not the funnest thing in the world. Okay, so confidence interval, let me just show you the calculation. It's p hat, estimate of p, plus or minus a margin of error. Okay, now proportions are always a z-value. Okay, so we don't have to worry about like, well, is there more than 30? Is there more than this? We don't have to worry about that. And then when you do times, we have p hat 1 minus p hat all over n. Okay, that is the formula we would be using. The calculator is going to take care of this for us. Okay, the hardest thing we're going to have to do is calculate p hat. All right, and I try to use the same language that your book uses so that we're not going to be too far away from it, because it is sometimes hard, especially with smaller numbers. Like, did you want me to use a confidence interval for a mean, or do we use one for a proportion? Okay, so we'll try to specify like, where do you tell? Okay, but the first one is just kind of like, let's just get into like doing this so we can get a feel for the mechanics, and let's see what happens. Okay, so for a given confidence level, find the following. Okay, we have x is equal to 47 and is equal to 97. I don't like this notation, but there we have it. And we want a confidence level of 80%. So the first thing they want us to do is take what's x over n, right? Usually when you're dealing with proportions, the context is that there's a yes or no question somewhere in the problem. All right, so what we're going to do is we're just going to say 47 divided by 97 equals, oops, not 9, 47 divided by 97, all right? And again, these are really sensitive to round off. We'll use whatever round off, whatever number of decimals that the book wants us to use for that problem. Okay, 4, 5. Okay, it goes on, but that's what we're going to use for right now. All right. Find the point estimate. Round numbers, answers to 4 decimal places. This is the point estimate. This is p hat. Okay, I took the number we got right, divided by the total. That's our p hat. Okay, so 0.4845. 0.4845. Before they yell at me, let's put in a leading 0. Okay. All right. Find the standard error. Okay, so this is like a last century kind of a problem. We're not going to ask you to do this specifically, but the standard error is this part right here without the z. Okay, so just this part right here. So what we're going to do is we're going to say 0.4845 times parentheses 1 minus 0.4845 divided by how many things do we have to do is 97, and we're going to take the square root of all of that. Let's take this in turn. So first thing, 4845, okay, times, well, 1 minus this, right? That's going to be 5155. Okay. 0.5155. Okay, so again, all I'm doing is making change. Okay, 4845. All right, 5155. All right, so what's that equal to? So 0.4845 times 0.5155, and about quarter-ish, right? 0.249. We're rounding to 4 decimal places, so 0.249. The 7 is going to turn into an 8, so 0.2498. Okay, and then we have to divide by 97. Okay, so let's go ahead. I would keep everything in your calculator. I wrote down 4 decimal places, but I really meant all of them. Okay, so divided by 97. Oops, I don't want that. I just want 97. Okay, and then we would write that down. So 0.2575. Okay, 0.00, right? 0.02575. All right, and now we want to take the square root of this thing. So we're going to say second function, square root, second function, answer equals, and then we get our answer of 0.0504. I'm sorry, 0.050, I meant 7. Okay, 0.0507. That's our standard error. Okay, 0.0507. Oops, let's not give it a reason for it to yell at me. All right, hooray. Find the margin of error. The margin of error, okay, remember, confidence intervals look like point estimate, or our estimate of our proportion, plus or minus a margin of error. So it's just this number here, right? Times, well, what's the value for, what do they want? They want an 80% confidence interval? Okay, 80% confidence interval. So do you remember what the confidence coefficient is? Or do you remember how to find the confidence coefficient? So for 80%, okay, confidence level, okay, what we're going to do is I'm going to go ahead and store this number. I'm going to go ahead and store it in A, because I'm going to need it back again. I don't want that one. I want alpha, and I'm looking for my A. Everybody's always looking for an A, right? Okay, there we go. Stored in the variable A. Okay, so let's store, come up with a number, a name for it. Pick an alphanumeric one. So alpha A, and then it's stored in A. So if I cleared all of this stuff, okay, clear, we could bring it back. We could say second function recall, okay, alpha A, and we should get the number we stored. Okay, so that's might help if you have to, like, if you need a number again. This like helps you bookmark it so you can have it handy. All right. So what I want to do is we're going to go to stat. Okay, and I want to go to tab. No, I don't want calc. I want distributions is what I want. And I use it again. Inverse norm. Okay, so remember that what we're going to do, right? We want 80% confidence interval. So what that means is that there's 80% here. What's left over? That's 0.10, 0.10, right? So what we're going to do is we're going to say we need a 0.1, okay? And then we need the mean 0 and the standard deviation of 1. Okay, so my confidence coefficient, 1.28. Okay, so what we're going to do is we're going to say this is 1.28 times this 0.0507 number. That is going to be our margin of error. Okay, so what we're going to do is say this one times, okay, second function, recall, oops, not that one, recall A. And it just puts it right in there for you. Okay, so I don't have to carry around those numbers. I don't need to record them. Okay, and our margin of error is 0.06. Okay, 0.065, we'll say 550. Okay, so what does this mean? The margin of error is about 6.5%. And we can change this to a percent, we get 6.5%. All right, so there we go. All right, give me a moment. There we go. All right, 6.5% is my margin of error. Okay, so whatever proportion I have, okay, in this case it was almost 48%, right? Give or take 48%, plus or minus 6.5%. Okay, so 48.5% plus or minus 6.5%. That's how you should be looking at this. All right. So my margin of error for the given data, 0.0650. 0.0650. All right. they're okay with that. Again, I don't know. I could see myself asking a question like this, but I can only see it like when you're, to kind of take apart the pieces that we've done to it in a bigger problem. All right, I couldn't see myself asking you just this and calling this 6 points, because I could see us. I could see me asking like for this one as part of a larger problem. Okay. All right. Use the given data to construct an 80% confidence interval for the population proportion P. See how they tell you, right? Construct an 80% confidence interval for this proportion. Okay, so I'm going to try to mirror that when I write my problems, because it tells you like, oh, am I dealing with a mean or am I dealing with a proportion? I think we're dealing with a proportion. Okay, and why do I think that? It's because they told me. Okay, so we have our x is equal to 55, n is equal to 70, and what did they want? They wanted 80%. Okay, so what we're going to do is we're going to go to stat, over to tests, and we have to scroll down to where we have the, see, there's our t interval. We did that one last section. This is our, no, don't want that. That's chapter 10. That's chapter 10. One proportion z interval. That's what we're looking for. Okay, we have one proportion. Proportions are always a z interval listed in this class. All right, so we're going to enter that. Okay, what is our x? Right? Our x is 55. What's the total number that we have? N is 70. Okay, and what did they want? They wanted an 80% confidence level. Look at that, there's 80% right there. 8.8, 80%. Enter, and here's our proportion. Okay, so our proportion goes from 0.7229, because this 6 here will make this a 9. And then we have 0.848. Instead of 5, we're going to have a 6. Okay, so here is a confidence interval, right? So interval is 0.7229 up to 0.8486. Okay, just reading them off the calculator here. 3 decimal places. Okay, so I'm giving them too much. All right. I don't like the problem like that because it doesn't give you a story. Oh, it's like a story. All right. See, this is better. So, among 248 cell phone users aged 18 to 24, 108 said that their phone was an Android phone. Find the point estimate for the cell phone users aged 18 to 24 who have an Android phone. Okay. So a cell phone. Well, we're not interested in you. Okay, market research. Okay, next, would you be interested in buying the Android phone? Okay, so we had 104 people. That's our number of people that said yes. That's our X. Okay, divided by 248. That was our total. Okay, yes, and total. So do you see like what we're asking here? It's not like how long do you spend on it, what you pay for it. Those are all like X values, right? For mu, for the first kind of confidence interval we did. This is like, do you have one? Yes or no? Okay, so that's what I'm saying is like, it's often the answer to a yes or a no question. Okay, and which one do they want? They want point estimate. Oh, they just want the point estimate. Okay, well, that's just going to be what I wrote down here. That's just going to be 104 divided by 248. Okay, done. So 104 divided by 248. Enter. Okay. How much do I want me to round by? 3 decimal places, 3 decimal places. Okay, so this is just 419, 0.419. Okay, almost 42%. Okay, this is 419. I'm only going to go to 3. Okay, 41.9%. 0.419. All right, check. And then off you go. It's slow today. We want a 99.5% confidence interval for these cell phones. Okay, so we're going to go to our calculators again. Okay, we're going to stat. No, yes we are. Stat test down to. Where's my one proportion Z interval? Two sample Z, two sample T, one proportion Z interval. There we go. Okay. So what do we want? We want 104, 104, and then 248. Okay, 248. And what do we want? We wanted 99.5. Okay. 995. Oh, they asked. All right. So my p hat, right? So here's my point estimate, right? 0.41. That's just, that number looks real familiar. So they even told us what it was going to be. Okay. So my proportion here, my confidence interval rather, 0.3314 to 0.50731. How many values do they want? 3 decimal places. Okay. So here's what we're going to do. We're going to say something like, here's 0.331 and then to 0.507. Okay. So somewhere between 33 and 0.14% and 50.7%. Okay. That's what we've got. Okay. So we want 0.331. Okay. And then 0. What else out of the way here? 507. All right. Well, all right. Assuming you said, where's an advertisement that claimed 48% of cell phone users aged 18 to 20, it's a very particular advertisement, okay, have Android phones. Does this confidence interval contradict this claim? Well, is 0.48 inside my confidence interval? Yeah. So no, it doesn't contradict the claim. You can say it's 0.48 if you want. You can say it's 0.4 if you want. Not an effective ad, but the 0.48 is contained in the confidence interval. Okay. So if there's that follow-up question, that's exactly what I'm going to ask you. Like, here's another claim. Do you think it's true? No, it's not my confidence interval. Yes, it is within my confidence interval. Okay. I can't tell the difference between any numbers between these two as far as this problem is concerned, right? So 35 might as well be the same thing as 45 as far as this confidence interval goes. 0.35 and 0.45, they are not statistically significant. I can't see a difference between those two numbers in this context. Okay. All right. All right. Let's see, we have 15 minutes in. Okay, but we're going to stop. Okay, I'm going to pick this up at another time. I got to get ready for other things here. But sleep apnea, go figure. All right, it'd be a good problem to do right now. There we go. Here we go. And there we go. All right, we're going to stop. But this is a pretty straightforward type of a section. Okay, so I'll walk through the rest of it on later. All right, so thank you very much, and we'll do another video a little bit later in the day for you.